All right, okay, so, all right, in this particular lesson, we're still going back and working on logarithms. So, if you have your notes in a nice and orderly, we're going to be back on week 17. But it's going to be new for today, and so if you're taking notes about what we're doing today, that will be sufficient. But when we go back and compare it, it's comparing with 17. Now, in the sections that you're assigned for homework this week, you're going to be doing 6-8, 6-7, and 6-9. 6-7, 6-8, and 6-9. Now, because you have already done the odd number or the even number problems when we went through this the first time, I am going to make an assignment on the odd number problems. Now, I said this before, the way that Forrester writes the book, the two problems that are next to each other, one odd and one even, have the same function as far as what is being tested. So whatever you did on the odd number problem, when you have the even number problem, it's the same skill, just different numbers. All right, so because you've already done the even numbers over here, right, when we do the odd number, if you're going to make a comparison on what you've already written, it's the same as the even number that's just past whatever number you're working on. Does that make sense? Hope it does. Okay, so on 6-7, all right, go back over the quick answers, 1 through 10. That's good practice. And then do 1 through 7 odd and problem 17, which is also odd. For those of you in Rio Linda. Okay, now in 6-8, we're going to do Q1 to Q10 again, just for practice. And then you're going to do 1 through 25 odd. 1 through 25 odd. Okay, now, by the time we get done with the lesson today, these two will be much simpler to do. Okay, now, the third one on 6-9, I want you to do 1 through 39 odd. Make sure you show the steps. And then as a project type, I want you to do all of problem 46. This is the summary of all of the skills of logarithms. It's a very good problem. This will take a while. Okay? All right, does that make sense? All right, questions on that part? No? Well, that's good. So either you don't want to talk or I did a good job. Okay, now, let's see if I can. I'm working with, thank you, ma'am.
Black is weak.
The black is weak. Okay. I need it strong.
Yeah.
But that'll work. Okay. All right, now we can try. All right, so, see, this is, my glasses, I got the other eye done yesterday with cataracts. So now I cannot look at that eye, look out this eye and read. I have to have glasses now. So if you'll just forgive me 1 second here. All right, so we are going to go back and look at 6-6. 6-6 was the last thing we did. 6-6 is scientific notation. That was last week. And if you remember, if you do scientific notation, let me see if I can get this to where I need it here. Okay. If you do scientific notation, let's say that I give you something like this. Whoa, I think weak is right. There's nothing in that. 3.2 times 10 to the 5th. Okay? Is that correct scientific notation?
Yes.
Why?
Because it's above 1 and below 10.
Because this has to be between 1 and 10, and this has to be a power of 10. Okay, so that's correct scientific notation. All right, now, suppose that you did some multiplication, and you multiplied and you came out with this, 23.4 times 10 to the 7th. Is this correct scientific notation? The answer is no, right? And what has to happen to this decimal point to get it in the correct place? It has to go down. Right? It's going to move to the left to make the power go, or make the mantissa go down 1. If this goes down 1, then this has to go up 1 in order to be able to not change the answer. Does that make sense? All right, so therefore, this becomes 2.34 times 10 to the 8th. Okay? Now, so let's do it the other way. Suppose you had a division problem and you ended up with this. .071 times 10 to the 11th. Okay? Is this correct scientific notation? No. What's wrong with it? The mantissa is too small, right? So this has to go up by 1 power, so this will go down by 1 power, and therefore there'll be no change. So this will become 71 times 10 to the 10th. Okay? Now, the highest degree difficulty of scientific notation is going to be where you have to multiply or divide, and the answer that you get is not going to be a correct mantissa. It's not going to be between 1 and 10, and so therefore you have to make a change. Now, if you're smart enough to make a change, all of it's easy. Okay? Does this make sense?
Yes.
All right, okay, so after you do multiplication or division of scientific notation when you're doing a test problem, make sure that the answer doesn't have to be adjusted. Okay, now, these were pretty easy to answer. All right, the hardest ones are like this. 47.3 times 10 to the negative 6. Okay, what's wrong with the mantissa? It's too big. So it has to go down 1, and so this has to go up 1. What is 1 above negative 6? It better be negative 5. Alright? Because that's the harder problem. If you understand it, and you understand how to adjust the integers, then you're going to be okay. Alright, and the same thing would be true if I had this. 0.114 times 10 to the negative 8. Okay? What's wrong with the mantissa? It's too small, so it has to go up 1, this has to go down 1. 1.14 times 10 to the negative 9 is 1 less. Right? Because we're talking about the order on the number line, we're not talking about the magnitude of just the number itself. Okay? All right, now, if you can handle that, the other parts of scientific notation are definition parts that are really part of Algebra 1. All right, in Algebra 1 in Forrester, he has very few of these problems. Only has a couple. Right, but in Algebra 2, you're expected to be able to handle all of that. All right, make sense? Okay, so, all right, so that takes care of the last chapter. So now we're going to move into the next chapter. All right, and I am going to get used to these glasses eventually. All right, so. All right, turn to page 264. 264. Okay, all right, first question. A logarithm is related to a what? An exponent. A logarithm is related to an exponent. If you have an exponent, what you're talking about is a base to some exponent equals a number. Right? Then the log of whatever base it is, in order to get that number, equals this exponent. So, test question. What is a logarithm? A logarithm is an exponent. Look what I'm pointing at. A logarithm is an exponent. Right now, it's more than that, but at the very least, the log is the exponent. Okay, that's a test question. Can I say that more plainly? All right. Okay, so do you need to know that? Yes, you do, if you want to pass that question. Okay? All right, so the first thing that happens sometimes is that you have this particular relationship that you have to find, right? And you do the manipulation. Now, what happens over here? All right, this is probably the harder part. If I gave you the log 3 of 27 equals 3. How do you change that into an exponent form? It's 3 to the third power equals 27. 3 to the third power equals 27. Okay? So whatever this base is, that becomes the big base number in the exponent form. Okay? Now, all right, that is page 264. That's the blue on 264. Now, they were talking about log 10. Why are they talking about log 10? Because that's what's in the calculator. Okay. All right, and therefore, in problem 265, this says log base 10 of 10. Well, we can say that this way. Log base b of b equals, right, equals 1. Because this says, if I take b and raise it to the first power, I get b. Right? Now that is important when you're solving equations that have logarithms or exponents, because this is a way to get at the exponent if the variable is in the exponent. Okay, so if you had 4 to the 3x power equals 7. All right, how do I get at this exponent? In order to be able to do that, I have to make where my hand is equal 1. Well, I do that by taking log base 4 of this side, and then log base 4 of the 7. And then these two equal 1, so I have 1 3x. So that's 3x equals log 7 divided by log 4. Right? And this, we'll go back over this. This conversion from different logs to base 10 logs is so important to know, because your calculator can get you this answer in a heartbeat if you have this. Okay? So that's what we're going to center on today. Okay, but so log base b of b equals 1, and then log base b of b to the x will equal x, because this is 1x. All right, there's a rule for that, but trying to be able to interpret the rule, that's the easiest way to do that. Okay? All right, now, okay, so now I've got to switch. Just a second. Let me get rid of this. Okay. All right, so now this one's a little bit similar, but you don't see this often. Log base a of 1. What is the exponent that I raised a to in order to get 1? The answer is 0. A to the 0 power is 1. So that's a property that's called the zero exponent rule, but it's not used that often. It's used more in what we did in the previous chapter, previous part of 6, where we had exponents. The definition of a negative exponent uses x to the 0 power is 1, because that's what puts the value to the bottom of the fraction. Okay, so this one is the one we just did. Log a of a equals 1. All right, so log base a of x plus. Now, the textbook starts with this, and then has this. Okay, so if you have a product, you can split the product into two exponents that are added together. Okay? Now that should not be news, but hopefully it's something that makes sense and you remember, oh yeah, I remember that. Okay? So, if you have a quotient, a division problem, you can split the division problem into two exponents that are subtracted. All right, and that's how this relates back to the earlier part of the chapter where we were saying that this problem, x to the a times x to the b equals x to the a plus b. All right, these are the exponents. The logarithms are exponents. So when I have this product, it's like taking the exponents and adding them. When I have a division problem, it's like taking the exponents and subtracting them. Because if I had this, I would have to have minus c. Okay? Does that make sense? All right. Now, if you have an exponent here, because of what the definition of the exponent is, let's say that this exponent y, let's say it's a 3. It means x times x times x. So I'm going to have 3 log of x's. So therefore, that y comes out into the front, and I'm going to have 3 log of x's. Right, so even if these two do not make a 1, you can still bring the exponent out. Okay? Alright, so that is 4, and the last one, I don't think this one had... Alright, yeah, alright, I'm going to show you this one. This is pretty cool. Alright, if log of b of m equals log b of n, that's only true if n is equal to m. Right, sometimes that'll come in. This particular drawing needed that. So then the one that's missing is the conversion. Conversion says if log base b of n, then log base 10 of n divided by log base 10 of b, or ln, which is natural log, that's base e, of n over ln natural log base e of b. And now this is the most important. So we're going to go over this a little bit until you say, oh yeah, I remember that. So if I give you, let's say that we're working an equation and we get down to this, where we have log base 5 of 15. Now, with your calculator, you can get that value. What you put in the calculator. Somebody should know. You're going to put log of the n, which is 15, close the parentheses, and then divide it by log of the 5. All right, do that. Make sure you close the parenthesis. Should give 1.68. Okay, now, if you only use 2 decimal places, your precision is not that good. So my suggestion is always use 4 decimal places. So this is 6826, and it's nice because we're chopping off a 0, 6. You see that? If you're chopping off a 0, 6, if you use 1.6826, you're going to be a little bit bigger than the actual number. You see that? Why? Because you truncated the 06194, right? So what you truncated was a little bit bigger than the number you're using. Suppose that you round it up. Let's say that we go to the 2, third decimal place. We would do 1.683. So that number is larger than the real number, right? And so when I put that in, instead of getting 15, I'd get 15 point something. if we go to the 4 decimal places and we trunk off, we get 14.99 something when we checked it. Okay? So, but this is important because most of your logarithm work is going to come down at some point to a base and a number that's not base 10. And so all you do is you put the log of this divided by the log of that, and it gives you the value. Now, just so that you know, do you see your LN button? I think to you is it blue log? Is that the LN? All right. Huh? It's under, right? So you have to do it. You have to do one of the second buttons, right? Okay. Do the same thing with log. Use LN. LN 15 close parenthesis divided by LN 5. All right. 1.682606.194. Same number, right? So does it matter if you have a problem? Does it matter if you have log n? Log or ln, natural log? The answer is no, not for what we're doing. Now, E. Okay? E is a value that's equal to 2.7 something. And it's used in science and it's used in economics. But just know that it's a base number that's something different than 10. So you actually have 2 base numbers in your calculator. You have the base number for 10. And you have the base number for E, 2.7, I think it's 2.708 or something like that, but at any rate. Okay, now, so let's turn to page 267, let's look at some of these. All right, problem 1. I'm going to ask you a weird question on problem 1. By the way, this is part of your homework. All right, in problem 1, what does the log equal? The log equals the exponent, right? Hello? Does the log equal the exponent? So therefore, log of what base? In problem 1, log of what base? 10, thank you, somebody. This says 10 to the x equals 397. All right, based on the definition, this is log base 10 of 397 equals the exponent, which is x. You can put that in the calculator and get the value. Right? Now, you don't have to, but you can, because all this is log 397, and that is x. So we've got the answer. Okay? Now, when you go to number 3, what problem do you have? Instead of having it equals x, it equals negative x. So that means that whatever answer you get, when you put it in here, you're going to have to make it negative, because we don't want the value of negative x, we want the value of x. Okay? So, all of those problems, 5 is the same thing. The variable is in the exponent, so you have to change it to a log. And isn't it nice that they use log of 10? All right, everybody say yes, it's nice. Why? Because we have log of 10 in our calculator. All right, but suppose that problem number 5 was this. 7 to the x power equals negative 2.1. Oh, wait a minute. I'm going to change that, because that's equals 2.1. Okay? Now, normally, we would make this into a base of what? 7, right? So therefore, this equals... I've been doing that for 20 years. This equals log base 7 of 2.1 equals x. Everybody agree with that conversion? Right, that's the first equation, right? Changing an exponent form into a logarithm form. But what happens here? This is the conversion that I gave you as the last equation. So what do you put in the calculator? Log of 2.1 divided by log of 7, and you'll get it. Right? Now, the book is letting this be 10 because they're afraid you might get upset if you couldn't get an answer. Right? But because you're Algebra II students, you can handle this. It's just a different rule. Right? Okay? So, if I gave you this, 9 to the x power equals 4. Right? How do you change it into a logarithm?
Log 9.
Log base 9 of
4
4
equals x.
equals x. Now, what do you do with that?
Log 4.
Put it in the calculator. Has to be less than 1. Why does it have to be less than 1? Because 9 to the first power is 9. So this number is going to be 0 point something.
Right here.
See that? Okay, so is this hard?
No.
Well, once you learn it, it's not. Is it hard? Yeah, it's hard. But is it doable?
Yes.
Yes, that's the rule. The conversion rule between bases, if you understand it and you can use it, logarithms gets much easier. Okay? Does that make sense? Okay, now, so now if we turn the page, and we go to problem 13, okay? Now, problem 13, where is the variable in problem 13? Hello? Question. In problem 13, page 268, where's the variable? It's in the exponent, right? So to get at it, what can you do?
Transfer it to
Right.
log.
Let's change it to log. So this says 2 to the x power equals 3. Change it to a log. It's going to be log base what? 2 of
3
equals. Can you put that in the calculator and get an answer? What do you put in the calculator?
But log 3 divided by log 2.
So this is a slam dunk. Right? Who's doing all the work? The calculator's doing all the hard work. We're just using the transformation, using the rule. Now, before I understood this, I didn't know what to do with that problem. Because it didn't make sense. And I'll tell you this, I was out of high school before I figured this out. I did not figure this out in high school. That's one of the reasons why I'm going back over it. It's not that simple, it's just applying the rules. I didn't hear that. My teacher probably taught me that because she was a good teacher. But I didn't hear it, and so I didn't understand that's what I was supposed to be able to do. Alright, so when we look at problem 15, do we have the same problem as we had in problem 13? Isn't it the same form? Now the numbers are ugly, but it's the same form. So if I make a logarithm problem, it's going to be log of what? What's the base number in that problem?
54.3.
Log of 54.3, right? Of what number?
17.2.
Of 17.2
Equals x.
equals x. Now aren't they nice? Okay, suppose that this would have been 2x instead of x. Then to be able to do this part, I take log 17.2 divided by log of what? 54.3. That'll give me 2x, and so what I have to do is 2 times that will equal x if that said 2x instead of 1x. Right? Suppose it would have said 2x minus 3.
So do you do that?
Then I would have done this, and I would have added 3, because that's how I get this to the other side. So it would have been plus 3 divided by 2. Right? So even if this is an expression, it starts out the same way, and then once it's in this form, all right, Log 17.2 divided by log 54.3 is a number, right? And so that number then has to have 3 added to it, and then the whole thing divided by 2 in order to get to the x. So so even the complex ones are simple algebra if you understand about the conversion into base 10. Okay? All right, now that's it for 6-8. So now 6-9. 6-9, we've just been over on page 269. We've just been over that. Okay. If y equals the log base b of x, then b to the y power equals x, right? That's just a conversion from one to the other. All right, turn the page. All right, look at example 1. Example 1 says, find x if log base 3 of x equals -4. Log base 3 of x equals -4. And that pen doesn't work very well either. Okay, now here my x is in a different place. If I change this into exponent, right? I'm going to write this so we can see it. Okay, now, this is the answer, this is the base, right? So this says x is equal to 3 to the -4 power. Now, if you put that in your calculator, you're going to get a decimal value, right? And in order to be able to work in Algebra 2, you have to understand, what do I do to get rid of the negative exponent? And the answer is you send it to the opposite side of the fraction. What part of the fraction is this in right now? It's in the numerator, right? So to be able to send it to the bottom, that's going to equal 1 over 3 to the 4th. Now that 3 to the 4th you can put in the calculator. If you don't know it. 9 times 9 is 81. So it'll be 1 over 81. But the key to this is understanding that after you get it in exponent form, before you start doing the work, because 1 over 81 is a decimal, and the calculator will give you a decimal, but you want this number as a whole number, if possible. So therefore, you take it to the bottom of the fraction. Okay. So, whenever you have whenever you have the x, the variable in the exponent, you have to change it to a log and then do the base conversion. Okay? Now, this set of problems, we have this. Excuse me. I don't want that. Sorry. We'll change that. I was thinking something different. Sorry. Let's do 2.5. Okay, what does this mean? This means 5 to the 2.5 power equals x. And 5 to 2.5 power is something you put in the calculator. With the XY button, 5 raised to 2.5.
55.9.
Something, right? You're again, if you do that, because it looks like it's an irrational number, you're going to have to round it or truncate it. All right, I like to take it to the variable where I can cut it off. I can truncate it, right? Instead of rounding up, because if you truncate it, usually the answer is closer to what you want. Okay, so if the variable that you're looking for is out here, or it's up here, then the conversion works. Right? If the variable is the number, then 5 to this power, because the logarithm is an exponent, 5 to that power will be the answer. Okay, that's what you're working with in this next section. Okay, so turn to page 272 and let's look at it. All right, log base 2 of x equals 3. All right, log base 2 of x equals 3. Now when I start to put this into exponent form, it is 2, did I do it right? Yeah, it is 2 to the third power. How much is 2 to the third power?
8.
So x is equal 2 to the third power, which equals 8, and I'm done.
Nifty.
All right, you see that? All right, now, why did I do that? Because in order to get at this, I have to change it into exponent form. All right, what would happen if I had given you this?
Then you put it as a logarithm.
You put it as a logarithm and say what? Log
Base
3 of 27 equals x. And then, now, what do I can't do anything now.
Well, now you do log 27.
Log 27 divided by log 3. So even if you did not know that the answer was 3, you could still get it using your logarithm rules just as easy as a math fact that you were supposed to know. Okay. Now, problem 13. Problem 13 is the third issue. All right, because we've had a logarithm with an x as a variable. We've had it where it's the value of the number. So now what we're looking at is where it's the answer. So log base 4 of 16 equals x. Okay, now, I don't have to change that one. I don't have to change that one. Why don't I have to change that one? Because we have a rule. Now notice, it isn't in the book yet. Exactly. We're going to do what? What, Ruben? The
log over 16 divided.
Log of 16 divided by log of 4. See? Now, because the book hasn't introduced it, it's doing something that's still legitimate, but that conversion rule means I can go right to the answer if I understand what the conversion is. Okay? Does it make sense? Because what this would end up being is 4 to the x power equals 16. Right? Now, I happen to know 4 to the second power equals 16. Right? But again, as far as math is concerned, to be able to come up with the answer, I can find that answer using the conversion rule and not have to worry about converting and then trying to hope that I remember that math fact. Okay? Now, all right, then we go to problem 31. Problem 31 says log x, log base x of 16 equals 4. Okay? Now this is a two-step problem. How do you change that to exponent form? X to the fourth power equals 16. Wait a minute, I have forgotten what we're doing here. I just forgot that. This one I think has to be a, yeah, this too. It has to, but we don't have a rule for that. You've got to know this. This happens to be 2 to the fourth power. equals 16, but we don't, one of our rules does not allow us to convert that. And what I'm trying to figure out is why do they have that here then?
They really hate us. They really wants to make us think.
Oh, I know what they're doing. I know what they did. Silly, silly. All right. Okay. What do I want over here? Don't I want x to the first power? Isn't that what I'm looking for? So in order to be able to get this, I have to raise this to the 1/4 power. That means I raise this to the 1/4 power.
Right.
Okay, so now let's try this in a calculator. This is the XY button. Go 16 raised to parentheses 1 divided by 4 parentheses. And you should get 2, right? Okay, so when the x is the base, you're trying to get the exponent to equal 1. So you're going to end up using the reciprocal of this number. Okay, now, that one right there was pretty straightforward. All right, let's suppose that we ended up with something really weird. If I ended up with x to the 3/4 power equals 7. Okay, what do I want over here? I want x to what power? X to the 1. What do I multiply this by to get 1? 4 over 3. And so I multiply this to the 4 over 3 power. It's not confusing, it's just math.
Yeah.
It's just math. Right, but that would scare most of us, right? And again, I forgot what we were, I was so much on the logarithms. You don't use logarithms for this one. You use the first part of chapter 6, you use your exponent form. Okay? Now, what is that going to be? Let's find out. It has to be, because it's 1 point something, 1.3, it's got to be greater than 7 and less than 49. Would you agree? See that? Because 4 divided by 3 is 1.333, right? So 7 to the first power is 7, 7 to the second power is 49, so my answer has to be somewhere between 7 and 49. Okay, so let's see, we have 7 raised to, let's see, 4 divided by 3, and I get 13.39. All right, you okay? Is that math related, I hope? Please let it be. Okay. Now, why did I stop at 39? Why did I stop at 39 on that problem? Because if I went to the third decimal place, the 5 would make the 0 go to a 1, right? And I would raise it. That would make it too large. Okay, so now let's check this. Let's check this. This says x to the 3/4 power equals 7. So our base number is 13.39. So put 13.39, raise it to the 3 divided by 4, parentheses 3 divided by 4. Now, the reason I'm telling you to do that is I want you to practice this to make sure that if you had this on a quiz, you'd have the right answer. What did I do wrong? Oh, I got the sign. All right, you get 6.9999.
7.
Right? Okay. You get 7? Oh, 6.99979. Right? But 6.999 is pretty close to 7, and so I have within the rounding error, I've said I've got the right answer. If I would have got 62 as an answer, then I would have done something wrong. Either I entered it wrong, or I made a mistake when I did the calculation. Okay? Does that make sense? Questions on that? Okay, so this section, if you look at, let's do another problem. Let's look at 37. All right, 37 says the log of base x of 81 is 4/3. All right, so therefore, we know that x to the 4/3 equals 81. Okay? Now, if I'm going to do this with straight algebra, I need x to what power? X to the first power. So in order to get x to the first power, this has to be raised to the 3/4. This is raised to the 3/4. Now, back in the dinosaurs' day, all right, which was, all right, the 4th root, 81, 3 times 3, and 3 times 3 is 81. So the 4th root of this is 3, and then 3 to the 3rd power is 27. That's going to be the answer. But let's see if you can get 27 by doing 81 to the 3/4 power on your calculator. All right, okay, you get the 27. Now, again, back in dinosaur days, before we had the calculators, this problem had to be something that we could do mathematically without a calculator. Now, what would happen if I would change this to 79? If I would change it to 79, on your calculator, the only two difference is the first two keystrokes. Instead of being 81, it's 79. Right? But 79 raised to the 3/4 power is whatever it is. Right? The calculator's giving us that answer. Does that make sense? Right, now, this is ugly. Only a calculator could get us that answer in today's world. Right? But the other ones, and some of the reasons that they're there, are because they are actually holdover from the dinosaur age when you had to think your way through problems of the same nature. Okay? All right, that's 6-9. Now, that's all your homework section, right? Okay, so now what we can do is have some fun. He said, oh boy. Okay. Now, how much time do we have? We got 15 minutes. Thereabouts. We go till 30, right? 20? 25, all right. So, all right, let's see if I can figure out where they are. Okay. All right, just big enough to see. Let me try to raise it up one more power. That help? All right, I'm going to also get rid of the old stuff. Okay, so now, if you had to get an answer for problem number 1, all right, and I will tell you this right now. This is a college entrance exam. Don't let it scare you, because you're supposed to know this in order to be able to get to college. It's the same stuff that we're doing. Only it's just set up to be able to separate those that can from those that think they can. Okay, so if you want this value, what do you do in the calculator? You do 0.6 raised to the square root of 3. It's just throw it in the calculator. So do it. All right. No, I don't get 4 point. I get 0.4. It's 0.4. Did you use square root? It's 0.6. Again, it's 0.6. Right, 0.41280, right? So the answer is 0.4128. And then cut off the 0 beyond. All right, everybody see that? Okay, now, on a scale of 1 to 10, now this is college level entrance exam. On a scale of 1 to 10, how hard was that if you had a calculator in your hand?
0.
It'd be 1, right? Okay. Huh? There are certain things, yes. There are certain calculators that you can use on national tests. And in this particular thing, do you know what 6 to the square root of 3 power is off the top of your head? Did you memorize that? No, so you'd have to use that. You'd have to use it. Okay? All right, now, this next one on college level entrance is something that we don't do that often because we don't have E. But you do have E. You have a button that says e to the x power, don't you?
Yes.
Look for it. Mine's next to the ln. Right? Second, and when you press second e to the x, it gives you e raised to the caret. Now, what do we have to put in? We have to put in 3.2. Everybody find it?
3.2.
And you get 2453, right? All right, you see it? You find now who didn't? If you didn't find the e to the x character, right now again, we don't use it that often in what we've done so far, but it's not a mystery because it's just one of the things that's in your calculator. Okay, and it's related to ln. Okay, now here's what I want you to do: go back and get that button out, and I want you to do e to the first power. All right, any number to the first power is a number. So what does e represent as a number? 2.71828, right? That's the value of e. And in economics and some other things, it's a doubling factor, right? And so it's used in some other things. And so you're going to find e on some of your physics that you get into and some other things. And e is just a number. What's the number for e? What is it? 2.7, right? 2.718. It's between 2 and 3. Right? It's 2.7. Okay? And so, now when we have regular logs, what's the base of the regular log? 10. Right? And when you use ln, that's a base of 2.7. Alright? Clear? As mud. Alright, now we're not going to do problem 3, but what would you do? Problem 3. You put
I just typed that
this
in.
number, okay, what's the answer?
You want to do it in calculator?
Yeah, oh yeah, I thought you just typed it in.
No, I would just type it in.
Oh, okay, yeah, you just type it in. You put 1.005 raised to the 400 power. Now, if it was 1 raised to the 400 power, what would the answer be?
4.
The answer would be 1.
Yeah, you're right.
Because 1 times 1 is 1 times 1 is 1 times 1 is 1. So this is going to be a little over 1. Okay. Now, what do we do here? Now, this is what I try to teach you today. When you have this, what do you put in the calculator? Log 64 divided by log 4. You don't have to worry about that. See, isn't that sweet? Okay. All right. Now let's see. Now this one. All right. Any number that produces a 1, the number was 0. The exponent was 0 to produce a 1. So that answer is 0, and I'm not sure what this one is. Again, that's just straight calculator, only you have to use a different button. You don't use the log, use the ln button. Let's do that one, just so you know. .9729.
That's 6.
All right, .9729. All right, what did you say again?
Something's wrong with my calculator. I keep getting numbers like slightly too big. It might be on a wrong mode or something. I'll try resetting it. It's not home.
Yeah. This should have asked, did you put square root of 7 close parentheses and then close parentheses again? And what'd you get?
9.729, blah, blah, blah.
That's the correct answer.
But I've got 0.
Oh, 9 point. No, it's
Yeah.
0.9.
Yeah, that's why I'm confused. I'm getting point offs. Maybe it's putting it in scientific notation.
That would be true. Yes. That would be scientific notation. So that's something on your, that's a setting on your calculator.
Okay.
Yeah. Yeah, I'd get that all. I would reset that thing in a heartbeat. Okay? All right, now. Okay, so now we're going to move to the next part. So, now let's go back. On a college level, how hard was that? That was easy, right? Because why? Because that's the definition of those particular terms and how you use the calculator to get it. Okay, now this next section says write as logarithms. Okay, so now this is asking you to change it into a logarithm. All right, so one of the things that we know about a logarithm, a logarithm is a what?
Exponent.
Exponent. So that means this has to equal 4. What equals 4?
Log 2.
Log of base 2 of 16. And that's all you have to do. Because that's all it asks you to do. Okay, now, next problem has a twist in it. Because you did not get told specifically to remember that this is 64 to the 1/2 power. A square root is the 1/2 power. So now I have this. So how do I change that into a logarithm? That will be what? Log, what's the base? What's the base of this problem? The base is the big number.
Sorry.
Log of 64, what's the exponent? Is 8. The exponent's a half, isn't it? So it equals 1/2. So log base 64 of 8 equals a half is the logarithm form. Now that has two things in it that are difficult if you weren't warned. The first thing is understanding what the square root is. And what I have found is I do not see a lot of Algebra 2 students that picked this up on Algebra 1. Now when I taught Algebra 1, I taught Honors Algebra 1, I stressed this big time. Why? Because you can't get through Algebra 2 without knowing that square root of 64 means 64 to the 1/2 root power. Okay? You've got to know that. All right, so that's the reason why that problem is in there, is it's finding out whether or not the person that's applying for this college, whether or not their math level has gotten to a good or gotten to a very good range. Okay, so that will help you get in very good. Okay, now, all right, 9. Okay, now, the only trick here, we don't do this often, but that's E. I've told you about E today, right? That's not the first time we've seen E. What is E related to on those buttons? Very good. Very good, Cindy. It's the ln. So instead of doing, so normally we would have said log base E, right? All right, we would have said log base E of 5460 is equal to 4. All right, but log base E is that right there. So we just say ln of 5460 equals 4. That top part is what you have to write. Right, again, so is that a piece of information that you can remember for the next 2 years?
Yes.
Hopefully. Hopefully.
Fingers crossed.
Right, and especially after you freak and say, oh gosh, I can't do that. Oh, wait a minute, now I remember. We did that. Okay, now look at this. Does that look familiar? Starting now, we'd have to figure this out, right? But this is the same as log base 10 of 10. This is log base E of E. So this part equals 1, and it's 1 negative 2. So that answer is negative 2. All right. How are we doing? 19. Isn't this fun?
Yes.
Isn't it cool? Now, and again, this is at a high level, folks. But is any of this past what you could do?
Nope.
No. Does it take practice? Yes. Does it take remembering? without a doubt. But these are not impossible. And so what does that mean about this particular test that we're taking? All right, can you handle, where you are right now, can you handle logarithms for a college entrance exam?
Yes.
The answer is yeah, you can. What you're learning is important, but you can't just forget it because we finished this test. All right, you got to remember some of it. Okay, now, evaluate with calculator. Boy, have we got this one down. All right, what do you put in the calculator?
Log 25 divided by 5.
Okay, what do you put in the calculator?
Log
1 over 81, close parentheses, divided by log 3. Slam dunk, yes.
Evaluate without a calculator.
Oh, okay, never mind, sorry. Okay, I'm not being tested for reading. Okay, now, without a calculator, you'd say 5 to what power is 25? 2.
Sorry.
Okay, 3 to what power is 81? 4. How do you get it to the bottom of the fraction? Negative 4. Okay? So, yeah, all right, now here's this is the change formula. Log 3 divided by log 7. This one, log 0.5 divided by log 2. Okay? Now, all right, this is base 10. All right, remember these two are products? So this is the log base 10 of 10 plus the log of x. And how much is this? You better know that it is uno. So this will be 1 plus the log of x. That would be the answer to that problem. All right, what would happen here? This is the ln of x, and if this is a product, what do I do? Plus the ln of y, and this is minus the ln of z. All right, that's those log rules in practice. All right, last one right here. Oh, you see the square root? What power? Half power. So that means the half power will come out to the front. Okay, so this will be the log of this. The 5 comes to the front, so it'll be 5 ln of x plus, what happens to the 2? The 2 comes out to the front, 2 times ln of z minus 3 times ln of y. Okay, so you are getting closer, all right? Okay, also, one of the things that, hope I still have it. No, I don't. Wait, maybe I do. Do I have 2 of those or 1? Nope. Extra credit project. Okay, it's due May the 1st. Now, as in our final for the first semester, all right, the extra credit project on page 455, problems 1 through 13 all are due May 1st. Okay, now I am telling you this proviso. Show some work unless it's very obvious it's a calculator problem. All right, but like in the work that we were just doing, if you put down log of 7 divided by log of 3 equals and then put the number, I'd certainly understand that. Right, but because this is extra credit, I want to see what you're supposed to do. And what we will begin doing starting next week is I'm going to give you a heads up on what kinds of skills are on the final test. The final test will be done in class. Okay, and we'll start at 8 o'clock so that you'll have 2 hours to do it in class. It's fair. It's a fair test.
How many questions is that?
I can't tell you right now because we're still debating over which ones we're going to use, but it's less than 30 questions. So it's certainly fair. The reason that we're going to do 2 hours is that I want you to start and stop and be done. So we're going to start at 8 because nobody has any class.
What's the percentage of the test that goes towards their grade?
You can check on
I think it's 15%.
Okay.
But that's what I think. But I'll tell you this. It is For a person that has a B, if you get anything above a 60 and you have a B average already, it is very difficult to drop it to a C. If you have an A average and you get 2 grades below, which would be above a 70, very rarely, unless you had a 90.2, you're not going to drop more than a point or so, because it's 15% of grade. All right, so if you get a decent result on the final, most of the time, if you think of it this way, if you have a 94, you only need an 89.5 to get an A. So if you have a 94, that means you drop 5 points. All right, to drop 5 points in your average is really difficult. All right, and so most of the time that doesn't come into play. The only ones are the ones that want to, if they have an 88 and they want to get an 89.5, so they get the A, they're the ones that have a little bit more pressure. All right, question? Oh, I thought that was a question. That's a twirling pencil. I'm glad you don't have that other thing. What's that called? Okay. Okay, I think we are done then.
Thank
you.
you.
Have a good day.
I'm going to go home and start my busy day.